All right, before the break, we were looking at saving and loading games. You'll need to do that for your final project, which is still a couple weeks away, but not very many weeks. Are those projects going okay? Everybody kind of got a start on it. It looked like the animations, most of y'all did an animation, at least on last week's with skeletal animations. It looked like you all were working on animations for that project. Saw a lot of those. Yeah, that one, it's hard to see in the classroom. The thing we did last week with the skeletal animations, it's that very tedious setup, but then we only do like two or three animations with it. So the setup takes forever, but you only have to do that setup once. So once you have the skeleton assigned, then anytime you want a new animation, you just reposition the skeleton. Or the inverse kinematics, that really complicated when we looked at having class where we just have the 4 points. There's only 4 points that we have to work with. And we just reposition those until we get every animation we might want on the character. So after the setup's done on really, really big games, the sort that don't fit in our classroom setting here, then it's much more worth it. In the classroom, the sprite sheet animation was probably a lot easier, or at least through a few frames. It's like, okay, that's all. Then I have to spend an hour connecting every bone to every piece of the image, or every piece of the graphics. But they did look really good. So, and I was just judging the animation, as always in this class. It's not a quality component on your artwork, right? So it just, I was just looking when I was grading those. I was just looking at how fluid the animation was. And I think I come doing grading over the weekend. I commented at least 2 places. I will set it in a minute. Remember, you can always resubmit stuff if you're not happy with the grade on it. And I try to be very thorough with the feedback. So if your grade wasn't so great on something, check the feedback on the grade book, and there should be lots of details telling you exactly what you need to do to get a better grade. You can resubmit anything. And yeah, when you resubmit stuff, it's still the original submission date counts, so it won't be like penalties or anything for fixing work. Because if we run out of time, what, 2 weeks from now? Well, I guess 3 weeks because we're at the beginning of the week. On May 12th, until we run out of time on May 12th, correct is better than quick. So takes time if you still need to do a couple things, and maybe expect some adjustments to the upcoming workload. But I'm going to dig through and figure out what we need to adjust. Oh, almost forgot a second time. There's a note, sort of an announcement. This week, after our class on Wednesday, I'm going to be heading up to Indianapolis, and I'll be there till Friday. So another one of those traveling weeks. So I won't be as quick as normal answering emails. I'll try to check them regularly, but this is another one, like, I guess the one 4 weeks ago where there was a 7 a.m. to 7 p.m. agenda with a few 10-minute breaks. So I'll try to check my email and get back to you as soon as I can, but it's not going to be like normal where I'm sitting right by the computer all day every day. Reply to emails almost as quick as I can. Okay, so the next thing is the next individual game project. And a couple people said that they hadn't got started on it or having trouble getting started on it. So it involved 3D modeling. And I guess really it's the reason we were looking at all that physics stuff earlier, so that we wouldn't have to do it all at once when we got to this day. Fit to it. If you need a little more time on this, take a little bit more time, because this is an important one, right? This is our accurate simulation instead of taking liberties with the laws of physics for aspects of a fun game. So, yeah, take more time as needed, because this is definitely one that we want to focus on getting correct. And it shouldn't be that big. Once you get the models made, using rigid body objects will handle all the physics. All we have to do is initialize the thing, and that's kind of what I was getting ready to walk through here. Let's see if we go to learning modules. I guess it started in module 5. So learning materials for module 5. Made 3 videos here walking through step by step through creating the models. So what is it, 17 minutes, 12 minutes, and 18 minutes. So each model is fairly quick to create. I only made 1 pool ball, and then you'll make 15 copies of that 1 pool ball, or and just change the color in them. Don't worry about numbers on the pool balls, because that's a little more complicated than it needs to be in Blender. So as long as you have like the colored stripes on there, it's like some of them are solid colors, some of them have stripes on them. That'll be enough for it. And then these videos kind of go through step by step, making the models. And then this document, you'll want to, I went ahead and looked up all of the masses and dimensions. So, right, the pool ball, you'll just create a sphere and then make sure it has the right radius. And when you load it in your game engine, make sure it has the right mass. That way they act correctly when they interact with each other. So you have all of those, the sizes you need. I have some models here. And I do not expect it to take that long. A lot of people said they haven't started it yet. This summer, I'm going to be having 8th and 9th graders do this that may not have any experience in programming, and we're planning on doing it the first 2 days of the summer camp. So that way we can get to programming robots by the end of the week. So people with no experience in programming, I'm going to walk them through this in like 2 days, and just the mornings of the summer camp. So it might sound overwhelming, right? Talking about doing an accurate physics simulation and all that, but it shouldn't. Once you get into it, I don't expect it to be that overwhelming. But if it starts to be, reach out, let me know. I'm always available to help. Do you have a question, Josh? Raise your hand up. So the text tool in 3D and Blender is kind of complicated.
I mean, couldn't you just draw?
So you have to do what's called UV unwrapping. So, which we saw in the 148 class. When you were in the 148 class, remember we made our model and then we laid it out on the flat surface and put it back together. That's the best option for putting the numbers on there. And I decided that would take another 20 to 30-minute video. So if you want to put the numbers on there, if you want to use the text tool, feel free. More is always acceptable. The instructions aren't the thing. I left it off there to hopefully make it easier for you. So I've got the models here. So actually, I think I can open these. So like if I open the 2 ball, you see, I don't think I've even changed the colors on this yet. It's still whichever one I created initially with the video. It's taking a long time to open. Oh, there it goes. Yeah, so it's still, I didn't even change the colors. I just made a bunch of copies, and then when I got to like the first one that had a straw, I think 9, then I changed that and then made a bunch of copies of that. So we have all the models here. So let's create a new project. And yeah, let me put this up here so y'all can see this. I turn the camera on. I can't see the thumbnail. So you can see this is all this is all we're gonna go over. So very, very short example. Actually, half of that's timer. So take like those 6 lines out. And that's all it's gonna take to it. So when we start talking about this, right, making an accurate simulation, all that stuff, it sounds like a lot. But once we get in here, it's really not gonna be that much. I'll call it full game. All the other settings like we normally keep on there. And we need to bring these in, so I'm gonna get rid of these back up. It also makes it a lot easier that Blender and Godot are fully integrated. So we can come back and make any changes to our model later, and they will automatically update in our game engine. I think that's important. Yeah, there it goes. All right, first thing we're gonna need is probably the pool table. Somebody want to tell me what kind of body we'll need for the pool table? Any thoughts? See, Justin unmuted. I didn't hear anything, Justin. Did you unmute to say that? Answer the question? So we have a couple types of bodies, right? If we pull up our list. So from these, which one do we want for a pool table?
Oh, yeah, static body 3D since you don't have to move around the pool table at all.
Yeah. Yeah, because the pool table is it's big and bulky. It's not gonna move, right? We're gonna treat it like a permanent fixture. So but yes, a static body. And then we can just drag our model up to be part of that. There's our graphics. But again, we probably want to access the mesh, which actually, like everything, we always want to access the mesh when we bring them in. So make sure you right click, and about halfway down the menu is editable children, so we can get to all the pieces of the menu that make it up. And then when you select the mesh, right, that's not really a simple shape. Oh, or sorry. Yes. Oh, these are nice. Thank you. It's new equipment time of year, so there's like deliveries almost every day. Those are Unihiker SBCs. So if you're familiar with Raspberry Pis, little single board computers like that, only a much more powerful one, and it has a touchscreen built into it. So really, really nice for if you wanted to like make a little handheld gaming system. We get in a bunch of the little things like that. But, sorry for the distraction. Okay. Oh yeah. So it's not a simple shape, but we probably want that shape to be exact. So a rectangle, just a big rectangle collision shape, our physical shape on here would probably not fit so well, right? We'd be missing parts. And to go through and do every single one, it's gonna take forever. So luckily, here in Godot and in all of our major game engines, when we have that 3D mesh or 2D mesh, if we use a mesh instead of static images in 2D, we have the option to create collision shapes. So once you see those children, and this button here at the top should appear, it says mesh and create a collision shape. Since we already, if you choose static body child, it'll create a new static body, but we already have the static body. So that's our logical body. Then the mesh is our graphical body, and the collision shapes are our physical body. So there's simple and complicated ones. The tri-mesh. Tri-mesh is going to make a perfect fit to that. It's going to perfectly fit the model. And you can kind of see there from those white blue lines that showed up, if they showed up well on the screen, those seem to show up well on the screen. But there's a lot of different shapes going on there to perfectly fit that. So obviously when we do that, it's going to use more RAM. But our pool table is not going to move or anything. So when we do it on a static body, it's more effective RAM usage. If we would try to do that on like a character and have a perfect fit to a human character that's running around and constantly changing, that's good. Using all that RAM and constantly swapping it in and out as the character moves would really start to slow the game down. The last thing, see, creating that here as a child of the pool table, basically, the graphics didn't clear our warning from the static body. So just grab that and drag it over to to what should be the parent. And ignore this warning. Yeah, a non-uniformly scaled collision shape. So there was an update on 4.3 that probably shouldn't have been updated, and they're working back around to it. So probably when 4.5 or 4.6 comes out, that warning about tri-mesh is going to be fixed. What it is remember how in other places we've seen if we click on our shape, there's size controls. For some reason in 4.3 they got rid of the size controls, and they're doing it all with the transform, resizing tri-mesh statics with the transform. But our scale transform data is not the best way to set the size in something. So that's what that warning is, and it should be fixed soon. But when we do a tri-mesh static, you just kind of it's not an error. Things will still work without it. That's all we need for the pool table because it's just going to sit there, right? Here, create a new folder to organize things in. All this, the folder is objects, and I'll call this table. Probably should have renamed this before. Didn't say it. There we go. So not much to the pool table there. Need a couple pool balls. What type of body is our pool balls going to be? I think back to when we were looking at the physics stuff a couple weeks ago. So those need to move completely with the laws of physics, right? Which one has all the laws of physics? Okay. I think I said it just a few moments ago, didn't I?
Margaret said in chat, it's rigid body 3D.
Yeah, thank you. Sorry. Thank you. Yes, I turned the controls off, so I didn't see the chat on my laptop. I see it now. Thank you, Michael. So rigid body, and I'll probably start with the cue ball. So I'll bring the cue ball up to be our graphics. I think this one I did make white. And it's just a sphere. So instead of trying to do the tri-mesh static, because that'll do weird things on the sphere, I could perfectly flat, but use a whole lot of meshes to do it instead of just the properties of a sphere. So for this one, I'm gonna add the collision shape manually. Collision shape 3D, and then just use a simple sphere. And then we can just set the radius for it. Oh, already closed out below. Then that text document has what the radius is. I happen to know that it's 0.028. So 28.5 millimeters. Which is just barely over an inch. Maybe I should have just kept everything in inches. The actual rule book, when I was pulling up all the dimensions and stuff, was all written in empirical units. I had to convert everything to metric, but our physics engine is set up for metrics, so it just made sense to kind of stick with that. So you can see that gives us a nice little solid tight alignment between what the computer is going to process is the physical shape and the graphics that we're seeing on there. Cue ball. And then really that would be more copy and paste, right? Once you have one of these objects, to get the other ones, just make a bunch of copies after you get everything set up. Because they're going to be a mass. I can't remember what it is on the paper, but it's something like 0.2, somewhere around there. Normal gravity. What type of physics material is it? Go ahead and set up just one ball and then make a bunch of copies, and then all you have to do is swap out the graphics for the other balls. Yeah, I'll go ahead and save that. Cue ball. And then we'll need our actual cue. Which again, it's something moving, so let's use a rigid body. You might call character body since we're going to control it directly. And the very first time I tried to do this, I thought the same thing. But then it became problematic because character body doesn't have all of the laws of physics built into it. So whenever it would, I had to do a whole bunch of extra coding to bring those things back in for the proper interaction when it hits the cue ball. And then everything's going to be able to, we need our full cue for the graphics. Editable children. I'll choose the cylinder here. I don't know why that material looks off. Might have to go back in and edit it. It should be brown material, but somehow I accidentally set the white material instead of just at the tip, cover the whole thing. But again, we can choose that and create a collision shape. We could put I'm gonna do a tri-mesh because in this situation, it's gonna be about the same as a cylinder. It's just gonna have the points at the ends and come down and map it on. It might be a little less efficient than a cylinder because it's doing triangles and squares, but collision shape at the end, or really, the collision shape could just go at the end of, at the very end, the little felt pad at the end of the cube. I'll go with this one now. Drag it over here to be the child of that. And somewhere we get a camera. And when I was setting up, it just made sense in my mind to put the camera on the pool cube because your cue needs to move around the table. You don't have to have a character holding it. If it helps visualize like the Invisible Man playing pool, that way we don't have to spend all the time putting together a character to hold that, and just have the pool cue floating around, and then it'll hit the ball. So I'm gonna the snap on. Yeah, snap. The first thing I'm gonna do is turn it around so that we're like facing. Why is snap on again? I just turned it off. I'm trying to set it up so it's like looking down the full view, something like that. I think it'll work when we get over there. Might have to come back and adjust it. We'll see it in place, but once we have all our pieces, then we can set up our actual pool hall. I'll call it that. With the valid name. So pool hall, and then to that we can add our objects. So we've got our table. And a cue ball. We have the table again, because apparently that saved the name. Next, we got a cue ball, a table, and a cube. So move the cue over here, or cue ball, somewhere looks like a good starting point. Right above the table. I'll zoom in on that. I always like to start things just barely above where it's going to be. If you try to get it in the exact right spot, there's a chance you might overlap the colliders, in which case everything would be locked in place. So I always try to start objects just barely above where the surface where they're going to end up, so that they're going to fall down there in the first frame. Right, it's going to fall down so quick once gravity takes over that we wouldn't. We're not going to notice that initial start, but don't have to worry about the physical shapes only over time. And then bringing our cue, bring that up. So it looks like that's backwards. So I'm going to turn that around. Actually, I could probably just go to the other end of the table. I'll stick with what I was in here. So that. Rotate 180 degrees around the Y, so it's facing the right direction now. And looking straight at the side, try to find a good angle and starting point where we're ready to hit the cue ball. Once the cue ball falls down to the starting position, should be just right in front of our thing, ready to hit. One other thing. The cue ball, we definitely want gravity to take over right away and just pull that down, right? Probably not the case with our actual cue. So I'm going to take the gravity scale and set that to 0. So the gravity no longer applies to it. Remember, we do have the freeze thing. We still need it to move, but I'll use the freeze here and come back to that freeze property in a moment. So we run this. There's only one scene, so go ahead and select the full hall as our default scene. Should at least see stuff. Oh, I think I forgot a light, didn't I? Oh. We talked about lights last week, didn't we? When we were looking at shaders and stuff. I'm just going to use the default one, add the light in the background scene instead of setting up a new one. Looks like that's about the right spot. I might need to bend the QO or Q down just a little further. And when you're setting up your code, make sure you're paying attention where, right, once you get these angles, make sure you're going to make note of what angle you need to be at least for your starting point and all that. Eventually, let's see, I think it's in the instructions, we use WASD to move around the table. That's pretty easy. That's just changing the position and always rotating as you move around, so that it's always facing the table. But you're up, and then use the arrow keys to adjust the angle a little bit. That one should be fairly straightforward, just adjusting your transform data. Run this again. All right, that looks like it's in a good spot to start. As soon as that moves forward, it's going to hit the cue ball and send that flying. So this is why we looked at that stuff earlier in the semester about the physics. That way we're not seeing it all at once. So we'll be controlling the cues. So I'll go over here to add the script to that. There's rigid body. That look, all that's what kind of what it needs to do. I don't know why that resets every time. Most things once you zoom in, they stay zoomed in anymore. All right, so we'll have two functions of, like normal. Initialization function, things only happen once. And then our process function. And this is a physics simulation, so we probably want to use physics process. Make sure we have the accurate physics. But just a reminder, if you're more concerned with accurate graphics, then it's just underscore process would be the one that gets called every single frame of the game. Then I'm just going to add some white space because I don't like typing at the bottom of the screen. So, we'll need some sort of input action. And this time I won't name it. I'm just going to use the space bar, but might as well name it. Let's add a shoot action. And all the stuff we've seen before. We're listening for the space bar or some joystick button to the back. That list of buttons if someone plugs up a controller. Could probably do a mouse click as well. And whatever options you want to set up for it. And then we'll listen for that input. All things we've seen before. Thoughts on this one? Should we do is action just pressed or is action pressed? So is action pressed, remember, it happens over and over again as long as we're holding the key. Is action just pressed, it's only going to happen one time. So it's a physics simulation. So we want to apply physics. We're to start applying a force to that to move it forward. Then it's going to hit that. Do we want to keep applying the force or just apply a force once? Yep. So yeah, Angela said once, and yeah, that's exactly what I was thinking. We don't need to keep applying that force. Because it's not a long going force, right? It's not like a car that's constantly moving forward in a racing game. With a full stick, we just jab it forward once, and then it hits the ball, and then the laws of physics take over from there. And again, the terminology I just used there, jab it forward once. When we were doing those things that were kind of like a character moving around, we were using impulse. Right? Time comes into play. We apply a force, but we apply that force over time to make it more even. But as far as just the sudden jab of the pool cue into the cue ball, it makes me think of something very simple. We're just going to apply that force once and then let it go from there. Apply a force, and then what direction is the force applied in? Don't need to be a 3D vector, and I come back over here to the graphics view. It looks like it's negative in the negative Z direction from the pool cue is negative Z. That makes sense? Everybody see where we got that? So, yeah. Negative Z is forward for our pool, whichever direction it is facing. Currently, it's Z is aligned with the world Z, but as we move around, that's going to change. We always have our local coordinates. Like a scripting tab. So nothing in the X, nothing in the Y, and we'll move something in the negative Z. And here we're just probably going to hone in on a number. I'm going to start at 35. I have something on the paper in front of me, but let's go through this whole process. Just to make sure it's going to work. So 30, I'm going to start at 35 and then kind of look for a good number for it. I'm going to hit it. Well, for one, we need to stop hitting it at some point, right? Because, yes, that equal and opposite reaction. It was going down to the pool ball, so the pool ball pushed back up on it, and there's no other force coming back. But it did move the pool ball forward. So after we do that, we want to stop it. So for that, we need to check for everything it collided with. I can't remember how we did it a couple weeks ago, but a good way to check collisions as our games get more complicated. I don't think we did this. Did we get colliding bodies? Oh, that's not the right one. For I and get, yeah. For I and get colliding bodies, so we'll pull up the document for this. Get colliding bodies returns an array of node IDs. It returns a list of all the bodies it collides with. Requires contact monitor to be set true, and max contacts reported to be set high, some high number. So those are just data fields built into it. I'll scroll up, I'll probably see them. There's a lot here. So those two are just data fields that we have to work with. So up here in the initialization function, we want to set that contact monitor to true. And then the other one, the max contacts reported. Just a maximum length for that array, because when we start colliding with all the objects in our game, frame after frame after frame, 140 times a second, that list is going to get really, really big, really, really quickly, right? So really, we only need one. We're only concerned with the cue ball, but just something that's high enough to count it. And we might bump the table or something, or another one of the balls, so we don't run out. But then that gives us an array we can loop through. Well, I'm going to do this. Right, the general process, figuring out once we have those array of colliding bodies, let's see what they are. So I'm just going to print it out, do a quick echo, see what it gets. So when I hit the space bar, looks like a cue ball and then all that other information about it. So it appears to be something we can get a name from. So I.name, right? Our general deductive steps to figure out what do we need. Okay, so I dot name is the thing we collide with, the cue ball. And even for that brief instance, there was a lot of collisions with that cue ball. Right, as soon as it hit it, the cue ball started moving and the pole cue started moving up, but seemed like an instantaneous collision, but we still got 5 of them. So they add up pretty quick. Then we can just check that. If I dot name is going to be cue ball, that's all we care about. And what I want to do is stop that cue from moving immediately. And the easiest way to do that is just to freeze it. We're gonna get this freeze property. I'll get that property path. We set freeze equal to true. And then when we're ready for the next shot, we'll set freeze back to false. So well, that's what I decided to do at the end. Along the way, I tried also just forces to slow it down. Vector 3 in the complete opposite direction. So I was trying things like this. So apply a force in the complete opposite direction. And we get into some of the unpredictable things of physics. Because it's not going backwards as fast as it went forwards. You see that in, but so the conservation momentum, the pool ball picked up some of the velocity that it was moving with. So then that backward force wasn't really equal. I found a couple numbers that kind of worked for honing in on things. So I think if that's 35, then that will go to about 12. It'll stop fairly quickly. No, that might be a little too high still. But honing in on numbers for backward force. But then we might want to, as the game progresses, you might want to set away so that you can hit with different strengths. Right? Sometimes you want to hit it really light, sometimes you want to hit it really hard. So when I was working through this, what I came up with was just set freeze to true at that point, and then we can after things finish moving around, then we can unfreeze it and kind of go move to the next spot and hit the ball again.
Good.
So it's moving, but that's pretty slow, right?
It also doesn't seem to want to go straight. So
Yeah, that's just because I'm not hitting. I must not be hitting in the center. Because that happens with real pool balls too, right? If you hit a little off center, it's going to go to the side. So yeah, some of that's working in there.
the digital pool usually will have some way to adjust where you're hitting it to that.
Yes. Which is just slight offsetting. So maybe it would make more sense to put your camera right at the front of the tip. So like I'm looking from behind the pool cube, maybe it would make more sense to have the camera way up here, so you can tell exactly where you're going to hit, or some sort of indicator, right? Like do a recast and make it visual so you can see exactly where it's going to go.
What would it look like then if you had somebody holding it and essentially the camera would be where their eyes are?
Yeah, that's what I would do. And I would set it up like a first person view, and then kind of down. So yeah, that would be like over here, depending on if you're left or right handed. It'd be just kind of off to the side and lean down, and that's what I was thinking, like lean over the pool cue and like look down. Is what I'm used to. But trying to think about some of those things you've done. So that moved really slow, but we moved faster. And just find some good numbers to start with. Okay, and probably address that so it doesn't. Right, that's only the cue ball would have code for that. Every other ball is just gonna disappear after you finish. After you finish. Find a good number. So that's moving along. Let's so then if we make a couple other put a couple other balls. The cube, and I think there's a duplicate. No, I'll come down here to the top floor. Cue ball, copy, paste. Oh. Yeah, it's trying to stop me from doing that. So what I do is just go to the regular File Explorer and copy and paste that file a couple of times. Full game. Objects. The cue ball theme. Copy and paste, paste, paste. Just put a few on here. Like a 1, 2, and 3. Which what I almost did there, we haven't really looked at that much, but remember we can't. The game engine is just typing a file for us. So you can see a lot of it's typed up in TOML. So that's what it would look like if you wanted to just type that scene yourself instead of using the editor. So now I have several of those. So probably one and switch the graphics out. Instead of the cue ball. Delete that and find I probably should use digits, so then they'd be in the same order. Actually, all of mine are the same color. I haven't changed the color. Save that. So I don't really even need to look for a particular ball. Delete this one. Break up the different graphics. And 3. Delete the all white one and bring in the different graphics, which on mine yet, because I haven't really bothered to do that. Save these. And then we can put a couple of those on the table. One. Two. There we go. So we should see something happen now, right? All these are rigid bodies. So once we get the initial force applied, the stuff built into the game engine should take over from there. Oh, that doesn't seem to be enough force to really carry through. So, click our script. And again, just trying numbers to find one that works. Or find the range. You could sit down and probably calculate exactly what it needs to be every single time. And that went. Um, Try this. But that part y'all can, right? Then it's just trying different numbers to find one that works. Maybe I could line that full queue up a little bit better with the ball. So that it hits it straighter. Well, from there on out, it's just little refinements on these things until you find a good number to carry this stuff through. Watch out for things like that. Well, why is that ball rolling to the right now?
Might be too close to the queue. I think it must be bumped way to the end of it or something. Yeah.
I'll move it to the table so it doesn't fall. It must get it really close to the table. It must be starting to rotate before it falls. There we go. Maybe a little bit faster, but at least it went straight that time. So you can see there, scripting is just kind of getting it started and then little refinements afterwards. There's not going to be a lot of scripting to it. The game engine is going to handle almost all of that stuff for us. I don't, that changes direction a lot when I hit 115. 125 is what I found when I was getting ready for today. But it must have been lined up just a little bit better than what this one is right now. Oh, I don't know why it did that. We try moving it just a little. Let's get it. Oh, maybe my full queue is actually what's crooked. Where's the transform? I did this last time. Y'all know the process for refining it. I was just trying to get it to hit that at least once, well, something. Then little refinements, little adjustments to find the right starting point. Um, see how far you can get on that. If you have any trouble with it, let me know. But for the most part, it's finding those starting points and then letting physics take over. It does not have to be like the full games y'all probably downloaded and played. All that controls are, you mentioned some of the controls, Josh, where it's like very well refined. I just want the physics simulation. So even if you just start from the starting position there, right? Bring the cue ball back to the like that where it would go after a scratch every time and reset it, and just try to work with that scripting, the physics processes. It's a little bit different than when we just code the character tricks, the character body stuff. Anybody have any questions about that? See where you go, do you see where to go with that one? Well, when you start working on it, if you have any questions, let me know. But that's gonna be the basic process. Just line things up, find the force that you have to start applying it with. And then the controls that have been in the instruction is use WASD to move around the table. And use your arrows to adjust the angle of the pull cube. So really you're just moving it around and then hit the space bar or something to start the physics going in the simulation. Because we don't have a whole lot of time. We're under very tight time constraints. So we got a lot of course objectives to cover here. The one you're probably more interested in, getting back to all the other stuff, the storytelling and the animations and all the fun stuff, is got the group project, which actually isn't going to be till next week, but people have asked for a little more time. So earlier, today somebody said they would like to get in breakout rooms and start talking to the groups. So I'll open up breakout rooms and then you can meet with your group and start talking if you want to. And then that'll be it for today. After y'all are done talking, you can head on out. Does anybody have any questions that might need addressed before stopping the recording? Okay, I've seen 5 seconds of silence means no questions yet. That was hopefully time to put something in the chat. So I'm going to stop the recording and then we'll do breakout rooms.